A carpenter can make at most 20 tables and at most 30 chairs per day. Each table requires 3 hours of labor and each chair requires 2 hours of labor. The maximum total hours that the carpenter has at his disposal is 96. A. Give 3 inequalities that express the condition above. And then B. Graph and shape the common region that satisfies the inequalities. Find the maximum number of chairs and tables he can make with the time, at his disposal. So the first one is we should write the inequality that expresses this condition. So let's first synthesize the question into tables and chairs. So he's making tables and then chairs. So the first one is the number of tables and chairs that he can make. And then the second one is the time that he uses. So each table requires 3 hours of labor. So the 3 hours is here. And then each chair requires 2 hours of labor. So the chair is 2 hours of labor. So the question is saying we should write the inequalities. But then the question says that he has 96 hours at his disposal. So therefore, using the time, you can write that, and using T for tables and C for chairs, you can write that 3T plus 2C is less than or equal to 96, because that's the maximum amount of time that he has at his disposal. And then the next inequality that we can write is that the maximum number of tables he can make is 20. So T is less than or equal to 20. And then the maximum number of chairs he can make is 30. So C is less than or equal to 30. So these are the 3 constraints that we have. So therefore, let's then graph these 3 constraints on a graph. So using this 3T plus 2C less than or equal to 96. Let's put T equals 0. You get 3 times 0 plus 2C less than or equal to 96. So dividing 2 by 2, we see that C is less than or equal to. So we see that C is less than or equal to 48. So therefore we have the point 0 and then 48. Then now let's put C equals 0. So let's put C equals 0. So we'll get 3T, and write it here, 3T plus 2 times 0 is less than or equal to 96. So 3T is less than or equal to 96. And if we divide through by 3, we see that T is less than or equal to 32. And therefore we also have the coordinate 32 and 0. So we have 32 and 0. So let me write the coordinates here. We have 0 and 48. And then we also have 32 and 0. Then we have T is less than or equal to 20. And C is less than or equal to 30. So let's go ahead and then graph this. So we have the point 0 and 48 and then 32, 0. Then we also have the point T less than or equal to 20, then C less than or equal to 30. So let's go ahead and graph these points on it. So we are plotting the graph of C against T. we are using an interval of 15 minutes on the c-axis and then an interval of 10 minutes on the t-axis. So we have the point 0 and 48. So 0 and then 48. 48 is a little bit above 45. So this is the point 0 and 48. Then we also have the point 32 and 0. 32 is a little bit above 30. So let's assume this is 32 and 0. So let's connect the two coordinates to form a straight line. So this is the line of 3t plus 2c less than or equal to 96. So the next one is to plot t less than or equal to 20. So this is the equation for t less than or equal to 20. And the next one is to plot c less than or equal to 30. So this is the line c less than or equal to 30. So the next thing is to find the required region. So let's take some points and find arbitrary points and find the required region. Remember that the inequality is 3t plus 2c is less than or equal to 96. So let's take this point, the point 10 and 15 for this region. So 10 and 15. So let's use this point, 10 on the t-axis and 15 on the c-axis. So this becomes 3 times 10 plus 2 times 15 is less than or equal to 96. 3 times 10 is 30 plus 2 times 15 is also 30, less than or equal to 96. 30 plus 30 is 60. And it is true that 60 is less than or equal to 96. And therefore, the point satisfies. The next one is t is less than or equal to 20. From the point that we chose, we see that the t was what? 10. And 10 is less than or equal to 20. So it also satisfies this constraint. The last one is 15 is less than or equal to 30. And it is true, 15 is less than or equal to 30. So therefore, the point also satisfies this constraint. So this implies that the required region is this region. So having found the required region, let's then go ahead and then the next part of the question is we should find the maximum number of tables and chairs that you can make. Let's start from here. This is the point A, this is the point B, this is the point C, and this is the point D. So let's find the various coordinates of A, B, and C, A, B, C, and D. So we see that D is 0, 0. Then A, you see that A is at 20 on the t-axis, and then on the c-axis is above 15, somewhere 18. So A is 20 and 18. Then B is at 30 on the c-axis, then somewhere a little bit above 10, around 12 on the t-axis, and therefore B is 1230. Then C is also at 30 for the c-axis and 0 on the t-axis, and therefore C becomes 0, 30. So we'll then take this coordinate and find the maximum number of chairs and tables you can make. So let's draw a table here for tables and chairs. So tables, chairs, and then now since it is the maximum number of tables and chairs you can make, it means that our objective function I is equal to t plus c. T plus C will give us the maximum number of chairs and tables you can make. And therefore, our objective function is T plus C. So the points are, the first one is A, and A is 20 and then 18. The second coordinate is B, 12 and then 30. And the third one is C. C is 0 and 30. And then the last one is D, and D is 0, 0. So we have 20 and 18, 12 and 30, 0 and 30, and we have 0, 0. So let's find T plus C. So I of A is equal to 20 plus 18. And what is the value of 20 plus 18? That will give us 38. So this part is 38. Let's find I of B. I of B is 12 plus 30. 12 plus 30 will give 42. So this part is 42. Now let's find I of C somewhere here. Let me find I of C here. I of C is 0 and 30. So it becomes 0 plus 30. And this is equal to 30. And therefore, I of C is 30. And I of D is 0, 0. So it becomes 0 plus 0. And this is 0. So what is the maximum value here? It is 42. And therefore, we can conclude that the maximum... Okay, so let me write it here. The maximum number of chairs and tables that you can make is equal to 42. 42 chairs and tables. That is what the maximum number that you can make. Shade the region P in the xy plane which satisfies simultaneously the inequalities y minus x is greater or equal to 2. 3y plus 4x is less than or equal to 48. Y plus x is greater than or equal to 6. X is greater than or equal to 0. And y is greater than or equal to 0. And the B part is use your graph to find on the set the maximum value of 8x plus 10y, stating the values of x and y for which it occurs. So from here we know that our objective function I is equal to 8x plus 10y. So let's take the various constraints and find their x and y intercept. So we have y minus x is greater than or equal to 2. So if we put y equals 0, see that minus x is greater or equal to 2. X is less than or equal to 2. So we have the point 0, 2. And now let's put x equals 0. See that y is greater or equal to 2. And therefore we have the point 0, 2. So we are done for this constraint. Now let's take 3y plus 4x is less than or equal to 48. Let's put y equals 0. See that 4x is less than or equal to 48. Dividing through by 4, see that x is less than or equal to 12. So we have the coordinate 12, 0. Then now let's set x equals 0. We will get 3y is less than or equal to 48. And dividing through by 3, you see that y is less than or equal to 16. So we have the point 0 and then 16. Then now let's come to this one, which is y plus x is greater or equal to 6. So we have y plus x is greater or equal to 6. So let's set x equals 0. we will get y is greater or equal to 6. And therefore we have the coordinate 0, 6. Then let's also set y equals 0. We'll get x is greater or equal to 6. So we also have the coordinate 6, 0. So let me write the sets of coordinates that we are going to sketch. So we have the coordinates 0, 2, 2, 0, 12, 0, 0, 16, 0, 6, 6, 0. And then the constraints are y minus x greater or equal to 2, y plus x greater or equal to 6, 3y plus 4x less than or equal to 48, x is greater than 0 and y is greater than 0. So we've drawn our graph. Let's go ahead and plot the points. So we have the point 0, 2, which is this point. And we also have the point 2, 0, which is this point. So let's join the two. Sorry, I made a mistake here. So for the x coordinate, if you put y equals, so for this constraint y minus x is greater than or equal to 2. So let's put y equals 0. The minus x is greater than or equal to 2. So if we divide through by minus 1, you see that x is less than or equal to minus 2. And therefore the coordinates are minus 2 and 0. So let's effect that changes. This part is minus 2 and 0. So I'm going to show it on this graph. So let's go ahead and plot the points. We have minus 2 and 0, which is this point, and then 0, 2. 0, 2 is this point. So let's ignore this point. So this is the line y minus x is greater or equal to 2. And let's plot this point 12, 0 and 0, 16. So 12, 0 is this point. So let me extend the x-axis a bit. So here is the x-axis. And then 0, 16. So 0, 16 is also this point. So let's join the 2 points together to form a straight line. So let's write the equation of the line, which is 3y plus 4x is less than or equal to 48. Let's then plot this coordinate 0, 6, 0, 6, and then 6, 0. This is 6, 0. So let's join. So this is the line y plus x is greater or equal to 6. So let's then find the required region. But my graph has not been drawn to scale, so we have to note that point. So let's find the point, the required region. So let's take a point somewhere here. Let's take the point 1 and 8. You can see that 1 and 8 is in this region. Test for this region and see. So we are using the point 1 and 8. So we have this inequality, which is y minus x is greater than or equal to 2. So y is 8 minus x 1 is greater than or equal to 2. 8 minus 1 is 7. And 7 is greater than or equal to 2. And therefore, the inequality passes this constraint. Now, we also have y plus x is greater than or equal to 6. So y plus x is 8 plus 1 is greater than or equal to 6. 8 plus 1 is 9. And it is true that 9 is greater or equal to 6. And therefore, that point also satisfies this constraint. And we have 3y plus 4x is less than or equal to 48. So 3y plus 4x is less than or equal to 48. 3 times y is 8. Plus 4 times x is 1, is less than or equal to 48. 3 times 8 is 24. plus 4 times 1 is 4. It's less than or equal to 48. 24 plus 4 give you 28. And truly, 28 is less than or equal to 48. So that point also satisfies that constraint. Now x is greater than 0, and it's true because 1 is greater than 0. Then y is greater than 0. It is also true. 8 is greater than 0. So it also satisfies this constraint, and therefore the required region is this region. So this is the required region of the graph. So let's go ahead and then find the maximum value of x and y and also the coordinates. So I'm representing it as a. So we have this point which bounds them. So this is a, and this point is b, and then this one is c, and then this is d. Now if you do it on a graph, you find that a, you see that a is somewhere 2 and 4. So a is 2 and 4. Then b is 0, 6. B is 0, 6. Then what about c? C is 0, 16. Then d. See that d is somewhere 6, and then it's also somewhere 8, and therefore d is 6, 8. So having found this, let's go ahead and find the maximum value. But remember that our objective function is I equals 8x plus 10y. So our objective function is equals to 8x plus 10y. So a is 2 and 4, and b is 0, 6, c is 0 and 16, and d is 6, 8. So let's find I of a. It is going to give us 8 times the x value is 2 plus 10 times the y value is 4. So 8 times 2 is 16. 16 plus 40 is going to give us 56. So here is 56. And let's find b. It's going to give us 8 times 0 plus 10 times 6. 8 plus 0 times 0 is 0, plus 10 times 6 is 60. So this will give us 60. Then let's go ahead and find I of c. I of c becomes 8 times 0 plus 10 times 16. 8 times 0 is 0, plus 10 times 16 is 160. So here is 160. Then let's find the last one, which is I of d, and that is equal to 6, 8. So 8 times 6 plus 10 times 8, and that is equal to 128. So this part is 128. Now from the question says that we should use our graph to find the maximum value of 10x plus 8x plus 10y. So you see that this is the maximum value. The maximum value is 160. And also state the values of x and y for which it occurs. So the values of x and y for which it occurs is 0, 16. So the maximum value is equal to 160, and it occurs at the point C, 0, 16. Show by shading graphically the region S of all points xy which satisfies simultaneously the inequalities y is less than or equal to 2x, and then y is less than or equal to 16 minus 2x, then y is greater or equal to x over 3, and y is greater or equal to 0, and x is greater or equal to 0. So let's take the first one, which is y is greater or equal to x over 3. So let's set x equals 0. You see that y is greater or equal to 0, and therefore we have the point 0, 0. Now let's also set y equals 2. See that if y is equal to 2, we have 2 is greater than or equal to x over 3, and therefore x is less than or equal to 6. So we also have the point 6, 2. So we are done with this constraint. Let's take the constraint y is less than or equal to 2x. So let's set x equals 0. See that y is less than or equal to 0. So we also have the point 0, 0. And then let's also set x equals 2. So if x is equal to 2, y is less than or equal to 2 times 2. So y is less than or equal to 4. So we also have the coordinate. Let me continue from there. We have the coordinate 2, 4. Then now we are left with this constraint, which is y is less than or equal to 16 minus 2x. So let's set x equals 0. Y is less than or equal to 16 minus 0. Y is less than or equal to 16. So we have the point 0, 16. Then let's set y equals 0. You see that 0 is less than or equal to 16 minus 2x. So I'm bringing minus 2x to this side. We'll get 2x is less than or equal to 16. X is less than or equal to 8. So we have the point 8, 0. So let's write down all the points. We have the point 0, 0, 0, and also the point 2, 4. Then we also have the point 8, 0, and the point 0, 16. Then we have 0, 0 again, which we've already written, and another point which is 6, 2. And then we have the lines y is greater or equal to 0, and then x is greater or equal to 0. So having drawn our Cartesian, let's go ahead and sketch. Let's go ahead and plot the points. So we have the point 0, 0, then 2, 4. So this is 2 and 4. So 2, 4 is somewhere here. So this is the line y is less than or equal to 2x. 8, 0 and 0, 16. So 8, 0 is this point, and then 0, 16 is this point. So let's join the 2 points. So this is the line y is less than or equal to 16 minus 2x. Now let's go ahead and then plot 0, 0 and 6, 2. So this is 0, 0, and then 6, 2. 6, 2. So this is the point 6, 2. So let's join that line too. This is a line y less than or equal to x over 3. So having finished sketching our graph, then let's find the required region. So let's take this point. You see that the point 4, 4 falls in this region. So let's test 4, 4 with our inequalities. But remember, we're given y is less than or equal to 2x. We're also given y less than or equal to 16 minus 2x. Then we're given y greater than or equal to x over 3. Then we're also given y greater or equal to 0 and x greater or equal to 0. So we are using the point 4, 4. Let's test it. So 4 with this constraint is less than or equal to 2 times 4. The x component is 4. So 4 is less than or equal to 8. That is true. So it satisfies this inequality. We also have y, which is 4, is less than or equal to 16 minus 2x. And 2x is 2 times 4. So it becomes 4 is less than or equal to 16 minus 2 times 4 is 8. So 4 is less than or equal to 16 minus 8 is 8. That is true. So that coordinate also satisfies this constraint. Then we have y is greater or equal to x over 3. So now the x value is 4. So 4 is greater or equal to 4 over 3. 4 divided by 3 is 1.3. So 4 is greater or equal to 1.3. 1.3. So that is true. So the inequality also satisfies. The point also satisfies this constraint. Then y is greater than 0. 4 is greater than 0, so it's true. It also satisfies this constraint. And x is greater or equal to 0. 4 is greater or equal to 0. It also satisfies this one. And therefore, the required region is this region of space. So this is the required region. So let's label the points. This is A, this is B, and this is C. So we know that A is 0, 0. What is B? See that B is somewhere 4 and then 8. So the point B is 4, 8. 4 somewhere here and then 8 is also there. Then C. Now what's the point for C? If we can't find it on the graph, we could just solve the two equations, which is this equation, simultaneously to find the point of intersection of C. So for example, let's just try it. So let me use equal to y is equal to 16 minus 2x. And then y is equal to x over 3. So this is equation 1. And this is equation 2. So let's replace y with x over 3. So x over 3 is equal to 16 minus 2x. So let's multiply through by 3. So x is equal to 3 times 16, 8, minus 3 times 2 is 6x. So we take this x here. X plus 6x is 7x equals 48. 48 divided by 7 will give us x equals 6.9. So we then take 6.9 and put it here and find the value of y. So y is equal to, from equation 2, 6.9 divided by 3. And then 6.9 divided by 3 will give us 2.3. So the value of y is 2.3. So this C is 6.9 and then 2.3. I equals 3x plus y. Then the coordinate for A is 0, 0. The coordinate for B is 4, 8. And then the coordinate for C is 6.9 and then 2.3. So we have 0, 0, 4, 8, then 6.9, 2.3. So let's find I of A. It's equal to 3 times 0 plus 0. So to give us 0. What is I of B? It is 3 times 4 plus 8. 3 times 4 is 12 plus 8 will give us 20. Then I of C equals 3 times 6.9 plus 22.3. So this one is 0, this is 20, and this is equal to 22.6. So this is 22.6. And from the question, it says we should use our graph to find the values of x and y for which 3x plus y is maximum. So what is the maximum value here? It is 22.6. So what is the values of x and y for which this is maximum? So the maximum value occurs at the point C, 6.9 and 2.3. Draw and indicate by shading the set of all points P of xy in the OXY plane which satisfies simultaneously the inequalities y is less than or equal to x plus 2, y is less than or equal to 8 minus 2x, y is greater than or equal to 4 minus 2y. Using your graph, find the maximum value of 7x plus 4y. So this is our objective function, I equals 7x plus 4y. So let's take our constraints. Y is less than or equal to x plus 2. So let's set x equals 0. Y is less than or equal to 2. So we have the point 0, 2. Then let's set y equals 0. See that we have x greater than or equal to minus 2. Therefore, we have minus 2, 0. Now, let's take this constraint 2. And that constraint is y is greater than or equal to 8 minus 2x. So let's set x equals 0. See that y is less than or equal to 8. And therefore, we have 0, 8. And let's set y equals 0. You see that 2x is less than or equal to 4. And therefore, we also have the point 4, 0. So we have the point 4, 0. Let me continue from this point. Let's take the next constraint, which is x is greater than or equal to 4 minus 2y. Let's put y equals 0. X is greater or equal to 4. And therefore we have the point 4, 0. Then let's put x equals 0. So you see that y is greater than or equal to 2. So we also have the point 0, 2. So let me write down the points and let's sketch the graph. So the first point, we have 0, 2, and then minus 2, 0. And we also have the point 0, 8, and then 4, 0. And we also have this point, which is 4, 0, and then 0, 2. So let's go ahead and then sketch this graph. We have the point 0, 2. So 0, 2 is here. We have negative 2, 0. This point is negative 2, 0. So let's join the 2. So the equation of that line is y is less than or equal to x plus 2. Now let's get this one. 0, 8. This is 0, 8. And then 4, 0. 4, 0 is here. So let's join the 2 points. So this line is y is less than or equal to 8 minus 2x. Let's plot the last one, which is 4, 0 and 0, 2. So 4, 0 This is 4, 0, and then 0, 2. It's also this point. So this is the line x is greater or equal to 4 minus 2y. Now, having sketched the graph, let's go ahead and find the required region. So let's take a point here. See that if we take this point 2, 2 in this region, let's test 2, 2. So we are using the point 2, 2. So we have y is less than or equal to x plus 2. So 2 is less than or equal to 2 plus 2. So 2 is less than or equal to 4. That is true. So the point satisfies this constraint. Now let me come and continue from this side. Y is less than or equal to 8 minus 2x. So 2 is less than or equal to 8 minus 2 times 2. 2 is less than or equal to 8 minus 2 times 2 is 4, which is 4. And that is true. So that point also satisfies this inequality. Then from here, we have x is greater or equal to 4 minus 2y. So 2 is greater or equal to 4 minus 2 times the y component is 2. So 2 is greater or equal to 4 minus 4. And so 2 is greater or equal to 0. And this is also true. And therefore, that point also satisfies this inequality. So you can see this point, this region is the required region for this set of constraints. So the next thing is to find the maximum value of 7x plus 4y. So let's find the boundaries. So this is A. Let's represent this as A, B, and C. What's the coordinate of A? A is 0, 2. And then the coordinates of B. See that B is somewhere, comes to 2, and then goes to 4. So B is 2, 4. And then C. The coordinates of C are 4 and 0. So having found this coordinate, we can then use that to find the maximum value. But remember that our objective function is I equals 7x plus 4y. And this is A, B, and then C. And these are our x and y values. So A is 0, 2, and B is 2, 4, and C is 4, 0. So 0, 2, 2, 4, and then 4, 0. So let's find I of A. That is 7 times 0 plus 4 times 2. 7 times 0 is 2 plus 4 times 2, that's 8. So this is 8. Then let's find I of B. Is 2, 4. So 7 times 2 plus 4 times 4. And that is 30. So this part is 30. And then let's find I of C. That is 7 times 4 plus 4 times 0. That will give us 28. So this portion is 28. So what is the maximum value? You see that 30 is the greatest value among the three. And therefore, the maximum value is equal to 30.